Good morning. So we'll start with session 2 on chapter chemical reactions and equation. Our session 1 was all about how to balance the given chemical equation, right? Because without balancing, the chemical equation will not hold because it will not satisfy the law of conservation of mass. That means whatever is there in the number of atoms in the reactant side should be equal to number of atoms in the product side. We understood how to balance the chemical equation. So here when I start with the actual chapter, I will not be again reteaching you all how to balance a chemical equation. Wherever I come across a chemical equation, it will be a balanced chemical equation only. So we'll begin with the chapter. So when we talk about the chapter chemical reaction and equation, what it actually means. That means substances, there are so many substances around us that always undergo changes. Now what it could be, or whatever we see around us, if it is undergoing any change, that can be a physical change or it can be a chemical change. Now what do you mean by a physical change? Physical change is something which do not involve any chemical reaction. Now for example, I'll give you a salt and water, I'll ask you to dissolve. What do? You dissolve that, right? Will any chemical change happen? Will any new product form in that sugar and water? No, you get a sugar solution in which there is a water and the sweetness of the sugar is added, correct? There is no new product form, or we can say melting of ice or melting of wax. Is any new substance formed with a different property? No. That means in a physical change, what we observe around us, there is no chemical reaction involved in it and no new substances formed. But when we see certain chemical changes happening around us, we see a new substances forming with some properties in it. Now what are the chemical changes around us? Say for example photosynthesis process. True, photosynthesis we cannot see from our eyes, right? But there is a chemical change involved in it. How is it? What is photosynthesis process? So in the presence of sunlight, green plants prepare their food. In the presence of carbon dioxide, they take in carbon dioxide, water. This will mix. Some reaction will happen. That is how, as a byproduct, glucose and oxygen is released later. Correct? Respiration. We understood about respiration and photosynthesis. Respiration is it's the opposite process of photosynthesis. What happens in respiration? Energy is required to break down the food molecule, correct? Glucose is broken down in presence of oxygen, and carbon dioxide, water, and enormous amount of energy is released. So these are all chemical changes. I can say burning of paper is a chemical change. That means when I burn paper, what happens? Some chemical changes will happen. Burning in the presence of oxygen, I get into ashes. Now that will have a different property. So physical change which do not involve any chemical reaction and no new products are formed with some different properties. Chemical change involve chemical reaction and a new product is formed. What could be the example? Photosynthesis, respiration, burning of paper, etc. So these are the types of reactions what we see in our day-to-day life. But let us now understand these changes what is happening. What is this chemical reaction? What do you mean by the term chemical reaction? We understood physical change and chemical change. But in chemical change, if it is involving some chemical reaction, what do you mean by chemical reaction? Now in simple terms, if I have to tell you, if I have two chemicals and if they are reacting with each other to form a new product, that is called as a chemical change. How do we define it? Chemical reaction is a process by which two or more substances react with each other to form a new substance with different properties. So what happens here? Two or more substances, they react with each other to form a new substance with different properties. Now the first example which I had taken in balancing of the chemical equation, I took a magnesium ribbon and I burnt that in the presence of oxygen. What was the new product formed? Magnesium oxide was formed. Correct? Now don't ask me 2 and 2 why I wrote. I said we are not discussing any of the balanced equations here. Okay? Magnesium ribbon, we burned it in the presence of oxygen. We got magnesium oxide. That means we got totally a new product. Actually, if I have to tell you what actually happens in magnesium ribbon is, in Diwali we burn crackers and all, right? So when you light them, how that sparks will come? Some sparks will start igniting. Similar things happen when we burn the magnesium ribbon. A dazzling light is produced and that burns into ashes. That is called as magnesium oxide. Magnesium oxide is a new product form. Magnesium oxide has a different property than what we had over here. That is something see here two substances are reacting with each other to form a different product, to form one product, right, with different properties. That is the meaning of chemical reaction. How do we represent it? I have just given one example. Hydrogen reacts with oxygen to form water. I can also say here now, magnesium reacts with oxygen to form magnesium oxide. I have just used the shortcut in writing. That means chemical equation I have to elaborate and write. Correct? So now always if I have to elaborate it, I will not understand how many atoms of magnesium I am using, how many atoms of oxygen I have to use, and by the way how many when the product is formed, compound is formed, how it is formed, right? That means we have to write it in such a way that I get the correct information. That means I have to write it in the mathematical form. Here we have written in the verbal form, because when we write in the mathematical form, symbolic form, formula form, that means we understand how many number of atoms involved in the reactant side and the product side. That is something we understand in chemical equation, right? Now reaction we understood, where two or more substances are reacting to form a new product. That means these are reactant and this is a product. Chemical equation, what do? We write this in the symbolic form. Now for example, hydrogen, I will write here, hydrogen reacts with oxygen to form water, right? So 2 and 2. That means now I know it is, I have taken 2 atoms of hydrogen, 2 atoms of oxygen. That is how I have got water. In water I have 2 atoms of hydrogen and 1 atom of oxygen, or we can say molecule. That we'll understand later, or you have already studied this part. So this is how we write a chemical equation. We elaborate it, or our work is done very simple here. We need not write in the statement form. That is something known as chemical equation. A chemical equation is a symbolic representation of the chemical reaction in the form of symbols and formulae. That is what we used. Instead of writing magnesium reacts with oxygen to form magnesium oxide, I can write this Mg plus O2 is giving me MgO after balancing, right? So this is something about chemical equation. Quickly if I recapitulate, any chemical equation when we write, we have to always write the balanced chemical equation, because it has to satisfy the law of conservation of mass. That means number of atoms in the reactant side should always be equal to number of atoms in the product side. So we have to always keep the chemical equation balanced, right? Which we studied in our first session. So when this chemical reaction is happening, or when we form an equation, that means there are many changes happening in the chemical reaction. What it could happen, as we told that totally a new product is formed when a chemical change will happen, when a chemical reaction will happen. What type of changes will happen? Various things that happen in a chemical reaction. change in state, change in color, evolution of gas and change in temperature. That means when I, for example, let me take this, magnesium is, we are burning it, right? Now, magnesium is solid. Of course, yes, it's a you get magnesium ribbon. Okay, so not like a ribbon how it will be, but it is actually rolled it. A small, assume that you have a small iron foil, how it can be, not too thick, not too thin, but you can roll that. So magnesium ribbon is like that. When it's solid, then we burn this. What do we get? We actually get ashes. That means, is this change in the state? One example I give you. It changed from solid to ashes powdered there. That means it evolved. Right? So, it is no more in the solid form now. It has changed the state. This is one example. Sometimes what will happen? You will understand as we proceed with the chapter. When we react to or more reactant, some gases are evolved. That means from a solid or from a liquid, it has changed the state to gases. Change in state of a substance from solid, liquid and gases. Either of them, depending on the given reactant. Yeah, now take this hydrogen, oxygen. Hydrogen is gas, oxygen is gas. What is this? Liquid. Change in state. Correct? So when a chemical reaction will happen, it can either change in state, condition 1. It can either change in color. That means, suppose you have taken one solution which is almost colorless, you add another solution to it. Immediately the color will change to pink, right? You will see these changes as we proceed with the chapter. So in a chemical reaction, there can be change in color. All this might not happen in one reaction. It can happen in different reactions. Evolution of gas. As we told, in certain reactions when we do, there might be some evolution of gas. Say in a particular reaction, hydrogen gases evolved, carbon dioxide gases evolved, right? So gases are evolved. Change in temperature. Change in temperature means when I take 2 or more reactant and I mix them in a test tube. And when I just touch the test tube has turned warmer. Initially it wasn't, but I can feel the warmth of the content, reactants what I have added. As I have added it, I can feel it. Now it is warm. It wasn't before. That means it can change the temperature depending on the reactant. So these are the various changes which will happen when we do the chemical reaction. Apart from this, there are also certain other things when we talk about chemical reaction. We'll discuss that now. Okay. There are some conditions involved in the chemical reactions. Now, what are those conditions? Now, we understood that first of all, the types of changes involved when we perform chemical reaction, gas is liberated, or evolution of gas, temperature, change in color, change in state. Apart from that, when we write a chemical equation, we have to understand from the chemical equation what actually is happening, right? For example, there is something called as, I have written here, heat, sunlight, temperature and pressure. That means a chemical reaction to happen. Sometimes, for example, magnesium ribbon, what are we doing? We are burning magnesium ribbon, right? That is in presence of oxygen. Some chemical reaction to happen or to break down, we have to either supply heat in the form of sunlight, temperature, pressure, etc. So that we represent by symbol heat as delta. Now for example, if I have to say calcium carbonate, if I heat it, I get calcium oxide plus carbon dioxide gas is released. Okay, that means I have to apply heat on calcium carbonate. I have CO3, C is capital, O is capital. That means I can put a symbol here. This triangle what I am writing here is called as delta. That is nothing but heat. Okay, you don't want to write this, write heat. That is also fine. Okay, so apart from that, otherwise I will tell I am supplying a temperature about 1000 degrees Celsius. Then I am getting calcium oxide and CO2, right? Anything, we have to mention it in this form. So otherwise simple, we write like this. Or if it is sunlight, write sunlight. Now sunlight is different from heat. Now heat is what we are giving it externally. Certain reactions require heat externally. Certain reactant require only sunlight, right? So we mention it like this. That is point number 1. That means if I read such reaction, I have to understand that I have to supply heat to calcium carbonate so that calcium carbonate will decompose into or break down into calcium oxide and carbon dioxide. Please check if the equation is balanced. It is balanced. You can check it later. So this is the first part. Okay. And assuming that its delta is nothing but heat. If I have written sunlight, it is sunlight. If I have written 1000 degrees Celsius, some exact amount of temperature what I am giving. Next, gas liberation. That means when a reaction is happening, there are gases liberated. How do we know that? Now carbon dioxide is a gas, right? I will simply put an arrow mark after carbon dioxide. That means when I supply heat on calcium carbonate, it decomposes or breaks down into calcium oxide and it releases carbon dioxide gas. How did I know it released carbon dioxide? That my arrow mark will tell me. It is releasing. It is going. That is why arrow on the top. Right? Precipitate. What do you mean by precipitate? Precipitate is which is left behind, which is settling down at the bottom. That means in a chemical reaction, if anything is leaving or anything is remaining, that is nothing but that particular salt is remaining, which is an insoluble salt. Now something is settling down means I have to put the arrow mark down. I have written an example. Lead nitrate reacting with sodium iodide will give you sodium nitrate plus lead iodide. Now lead iodide is an insoluble salt. That means lead iodide is a precipitate. Now how will I come to know this is precipitate, this is not precipitate? Why? Even this could be precipitate. That is how we understand in chemical equation. More and more we go on practicing the equation, we will understand. See, there are again different types of chemical equation which we will be dealing with that later. You understand that by practice. Now here lead iodide is a precipitate. How did I know? I have already given an arrow mark down. If I give the arrow mark down, it is understood that it is a precipitate. What is precipitation reaction? A reaction in which it which gives out insoluble salt or in which insoluble salts remain are called as precipitation reaction. Right? A 1 mark question it can be asked. Last one, physical state. When we write the chemical equation, we have to also mention the physical state. That means, for example, I have written an equation here, iron. Iron is in which state? Iron can be in molten also, correct? That means I am using iron in solid state. I am using small letters here in bracket. What does this tell me? Iron is in solid state. Copper sulfate is in AQ I have written. AQ is something called as aqueous. Aqueous means when you mix water in it, it is called as aqueous state. It is in aqueous state, which gives you, now then what is the difference between liquid and aqueous? See, certain metals or certain things is already in the liquid form. That means that is not aqueous. Aqueous is something when you add water to it and make it a liquid form. That is aqueous. Aqueous and liquid are both different terms. See here, we use S, we use L for liquid, we use AQ for aqueous and we use G for gases. Right? Liquid is in originally liquid form only. Aqueous is when you add water and make it a liquid. You will again understand. See, now it is difficult for you to assume that how we can understand aqueous, how we can understand solid. We understand this as we gradually move on in this chapter. Okay. So copper sulfate is aqueous. It gives out ferrous sulfate, that is an aqueous form, and copper, which is a solid. Right? See, here I have given general examples. I have just mixed irrespective of what reactions they are. just to make you understand, we have to write these states here. Now, these are about conditions in chemical reaction, right? So, the next would be types of chemical reaction. What are those? Combination reaction, decomposition reaction, displacement reaction, double displacement reaction. Here exactly we understand the whole scenario of what we have studied in detail. We will be doing this in our next class. So in today's class, whatever we have understood on chemical reaction and equation chapter, if you have any doubt, you can call on the same day of the video session. Thank you.